Well, this is going to be a long conversation that we're all going to have. You, me, everybody else. If this is your first time watching, I want to say welcome. If you're a repeat offender and you watch my channel a lot, I say welcome back and thank you. Today, we're going to talk about these couple parts. I got the ISO gain turned way down on the camera for a reason. So it's going to look a little dark. But that's to make it so that the part numbers aren't completely washed out by the incredibly bright working lights I have here. What we have hooked up here is a Toshiba. We have a current run HG 2879 16D08 and the HG 2879C. But the lot number you'll see is completely different than the one that's a current run. And I want to talk about a couple things. So let's start covering this thing from the top to the bottom. We're going to take our cheap Atlas transistor checker. This is a good piece of test equipment for the novice or the beginner. I still use it regularly because it just basically tells us if the transistor is good or not. And with MOSFETs, it tells us what our gate set voltages should be. And there's some good handy points inside this transistor, but to give you an absolute gain test on each one of the transistors, it's a general tool of measurement. It's not hyper accurate. When we get a little bit further in the story, I'll explain. I have lots of transistor checkers, and I have a very expensive professional curve trace machine, which I've used exactly once, and it has to do with this transistor here. So first off, let me show you something. This is the venerable, been around for 40 years Toshiba with actual gold leads on it and the real material make foot. Okay? See, this one's a red dot, so that means the foot has no beryllium in it. It has a gain of 81. Let's set the Toshiba aside for a minute. This transistor checker is a relatively old piece of test equipment as far as the radio or electronics world is concerned, because this particular design is probably 10 years old at this point, which is old. But I get the same amount of data out of this transistor checker as I get from my transistor checker that is 55 years old, 60 years old, this old guy, with a neon bulb in it. This tester's telling me I have a gain of 37. Now that gain number changes depending on how much current you're actually able to apply to the transistor. But my argument has always been, if the current level doesn't change from transistor to transistor, how is it that we have such a wildly fluctuating gain level? But the manufacturer of the HG says that no, the gain numbers actually come up even higher as you increase your current load potential. And I agree, I have a transistor checker here that has verified that data. So the statement is not factual. It's just, if you have this tester and you test this part, it's telling you that you have a beta gain of 81. I should be able to go to this transistor, and without changing our load potential, that means this transistor also thusly the gain comes up even higher than 81 underneath load, if that makes any sense. The question's always been, well, why do they test different? And the North Corporation says, oh, well, it's because their load is so limited and this transistor checker has a little 3.5 volt battery in it. Sure, I get that. When I go to this tester, it runs on a D cell battery, which has got more current to it. It usually shows a slightly higher gain structure, but I got a transistor checker that allows me to put 150 amps on the transistor if I wanted, even though these transistors only pull 25. Okay, so the C has got a gain of 47. Now I've already done this speech twice. Let me say that up front. We're done with this. I've done this speech twice already. I did it in my personal Facebook group, and then I did it again on my personal page on Facebook so it could be shareable. Now, what I thought was interesting is there's only been one technician that's had any kind of pushback on this. And it was really shocking to me that several people came and told me about it, and then I went and I took a quick look. And it was amazing to me how he took away from what he wanted to hear. Because he wants to be right. I understand that. I'm empathetic to that plightful situation that he's in. I disagree with a couple of his points of view, but that's okay. It's my opinion. He has his opinion, and guess what? We live in a democracy where we're allowed to have difference of opinions. I don't know. I don't focus just on transistors. I have the whole table that I play at. From a single 2290 all the way out to, 40,000s and 100,000 E-tubes. So, I don't know. You take from this what you want. Let's go and start here. This is our part number that has started the whole mess. And the main point that I wanted to get across in the video was that there are certain parts that are somewhat interchangeable. And I said this on my Facebook videos, both of them. And what I said was somewhat somehow got translated to absolute, and that's not the case. So let's clarify here for people, since people want to take things out of context. This is the newest part from HG. This has actually been around for a long time in my book. These parts originally came to my knowledge or into my field of view back when Brian Smith at Truck CB Sales was a dealer. He was a dealer for about, I think 2 years, and then he got tired of paying the dealer fee, so he was just buying the transistors and reselling them. He was buying them from ICA Manufacturing and reselling them back to us, just supplying us guys that like to work with him, which I thought was super cool. And he's no longer even in that game anymore because it's not profitable. I mean, it's not really a profitable thing. But at that time, North was looking for not just an amplifier builder, a box builder, but somebody that he could get verifiable, repeatable data from, right? And he wanted a little bit more than, hey, I built an amp and built an amp around it, and this is what it did. He needed real data set points, and that's when our paths crossed. So my first question to him was not how many free pieces am I going to get and when can I expect to see them, because he was starting to circulate these components around for people to start doing tests on. My first question to him was, well, what transistor checker do you have? And he had a Tektronix, and he told me the model, and I went out and I bought it. It's a 52 something or other, I do believe. I looked the model number up. I don't want to go dig into the closet. I've used it one time. It sits in one of my guest bedroom closets, and I haven't done anything with it ever since. I looked it up on the Facebook videos, but I'm not going to bother with it today. The point is, when the new test pieces finally showed up, first I got out a 2879 and ran it through the curve trace machine, took a bunch of pictures of the screen because it's a phosphorescent screen. I mean, it's a little dated, but when the company that comes to you and wants you to verify their test points, you have to use the same equipment or rough to it to verify that data point. You have to, otherwise you're just producing gobbledygook for knowledge. So first thing I did is I produced curve traces with the Toshiba, okay? And then I came back and I gave him the curve traces of the 2879C. They are drastically different. And the curve trace machine tells me the whole story of what the circuit needs to be that surrounds the transistor. Very basic. Anywho, let's start telling the lineage of what happened here. They quit making these in the 90s, late 90s, early 2000s. A little bit of a mystical date when they quit making the Toshiba. You hear a lot of different stories. I haven't bothered to research it that much. I just know they're not in manufacture anymore, and the plant that they were being manufactured in has long since disappeared. It's now urban sprawl. So with this being the go-to Mac Daddy, always been available, the gold standard to which we're trying to achieve, this company in China started to produce multiple different styles of transistors, trying to get into this little bit of a market share. So what happened is the first couple sets of transistors that they produced, the first 7 or 8 years worth, weren't all that really impressive to us. And they were producing underneath multiple production line names. Okay. The HG name, they've always used that. It used to be H and then a little small G next to it. Then they went to just a straight H here in the last couple of years. But these are all Haigu transistors. And this is just a rough, small hand grab of transistors that I have sitting here. What I wanted to show you guys, we actually need to go back up to here. My big concern when I started doing the test pieces for North was that there was going to be a level of confusion that took place, and I'm seeing it happen. And it was the main thing I wanted to point out in my 2 previous videos I did on Facebook, is I wanted to dispel this notion that was taking place, because I started having a lot of people call me and ask me this question, and I was like, well, no, that's not how that works at all, and that's actually going to cost you your parts. The thing that's going on is they're looking at the part number, you guys. Look, you radio operator guys are smart. These guys that have been in the transistor amp game for a long time, you're smart. You understand that this is your part number right here. 2879, this is your part number. No one looks at this down here. See that? 1K, that's our date of manufacture. Yeah, supposedly 2001. And then the K stands for the month of the year. That set point got lost in the Chinese way of thinking. It just has. There's no other nicer way to put it other than that doesn't mean anything to them. And so North, them guys at the North Corporation or Haigu or whatever his real name is, I'm just going to start calling him North from this point forward. North started developing all these other transistors. Well, the first couple years of the transistor development, the transistors were garbage. I mean, absolute garbage. Okay? And we're talking like 100% failure rate on a component. You put anything more than maybe 13 volts on them, they blow up. Or you get an SWR of 1.5, they blow up. Or you didn't have all your capacitors, all your little ducks in a row inside the box, and they just instantly all detonate. And it wasn't worth it, because the Toshiba at the time was still like 40, 50 bucks, right? Well, some of us came along, we started buying a lot of transistors because we knew we were going to run out, and we wanted to have a stockpile to be able to continue doing repairs. Well, some of us didn't realize how close to the end we were, and so when we started mass buying transistors, $10,000 at a whack or so, the way RF Parts responded to that is the first thing they did is they cut off all the major builders and said, we're not going to be able to give you a discount anymore. When you go and buy large quantities of transistors from a supplier, the price goes down. Okay? So let's say you show up and say, hey, I need 1,000 pieces of this. Well, a single piece unit, let's say, is $20 out the door. If you buy 1,000 pieces, that price drops to like 11 bucks. All right? So it makes sense to buy parts in mass. It's an industry standard. Everybody's very understanding of that. They get it. Well, RF Parts being, quote, the only licensed importer of the Toshiba, they said, well, they weren't able to get any more, and Merritt's motivation, at least what he told everybody, what I believe is completely separate to what I was told by Merritt himself, was he wanted to hold on to as many of those as he could, and he didn't want to do mass sales. He wanted to be able to keep them around for repair. Okay, it's a legitimate argument. So he quit doing the mass sales. So that's when we started having other companies go out and start fishing the market, casting a reel and seeing what would come back. This is so old of amplification style that the amateur community and primarily the CB community are pretty much the only consumers of this thing anymore. So when you go fish into the market, there's not a lot out there in the ocean to get the parts pulled from, because it's not profitable unless you're making millions upon millions upon millions of transistors at a whack for the major corporations to get involved. This one company in China was willing to take up the slack and make an attempt. So this here is a DEI 2879 lot. This is where it starts to get very important. 13-3Q. The way I like to think of it is generation 13, attempt 3Q. Okay? These are not interchangeable parts, but they have the same part number. So now we have lot 14-2Q. Okay? And we got lot 15-3Q. Well, in between here and here, there's about 12 different lot numbers. Right here. 12 different revs of transistors that are not interchangeable. And the same thing that takes place here between 14 and 15Q, 3A, BD, whatever, not interchangeable. The same thing was happening over here. The companies that went and started consuming these components, they were only able to get what they were getting fed, right? So we have hundreds upon hundreds of amplifiers that were built with these, and then hundreds and hundreds upon hundreds of amplifiers are built with these, and hundreds of amplifiers that were built with these, and hundreds that were built with this style of transistor, but the lot number 15XH. But then over here we got a 16XH. These two parts are not interchangeable. And simply because the internal wafer structure of the transistors will fight each other and kill each other. So if you have a 2-pill that's got a 15XH in it and you have one transistor pop, you take one transistor out and try to replace it with another PP100, same part number, but different lot number or rev number or attempt number, 16XH, and I'm just using these as references. I'm not saying this is an absolute guide. They'll kill each other because the gain structures and the way the transistors operate internally are slightly different. Okay, so we have 16-1C here. So this transistor technically falls between this transistor and this transistor. Now, this is really hard to figure out. This is something you had to have been involved with or have somebody like me explain to you the structure chain. Why? Because if you go to look at the data sheet for the DEI, PP100, or even the HG, even up to the current rev, is literally a 2879 data sheet where they have scrubbed off the Toshiba label and they've just reinserted HG or DEI or PP100 or whatever they wanted, and they never bothered to update the data sheet from rev to rev to rev. Hence the reason that we live in a world where if you have a Blue Label X-Force that's full of PP100s, we don't know what they are. And the only person that would even have a clue but never bothered to document it at least far enough that the rest of us in the known universe can have is you know who. And he's no longer in business or whatever's going on with him. I don't know, not my concern. I don't care. We don't have any cross data for that. My only concern is we were working through this entire process, which took 7 or 8 years for all of this to develop, was we were trying to achieve this as our gold standard. We needed a part that we could drop in to a circuit that had already been pre-existing. The circuit we'd have developed for 30 plus years of the Toshiba. And what do I mean by that? I want to be able to take the part that is being supplied and put it inside of a circuit that is relatively close to the same circuit that we produced for the Toshiba. It's going to have the same reliability standards to it. Otherwise, it's tolerant to the same voltage, is tolerant to the same aspect ratio, is tolerant to all the same parameters that are in the Toshiba. When they finally came up with the 16D08 transistor, that's when we got really close. This is the closest rev that they've had out of all of them. And we're talking hundreds and hundreds and hundreds of tries, right? The parts were getting consumed even though they weren't the greatest because the boxes had to get built. I've just stuck with the Toshiba. Hasn't been until the last couple of years I started using these transistors. I've had a lot of good luck with these. But when these came along, that's when I was like, whoa, pump the brakes. And like I said in the Facebook video, in the other Facebook video, these two parts are somewhat interchangeable. This is the closest one we have, right here. Now, if you have a Texas Star or something like that, you can take the Toshiba out and you can install an HG 16D08 in its spot, and you're going to have relatively the same performance, which is exactly what I've said in both previous videos, because it's a fact. Are you going to get absolutely the best performance that you possibly can out of this transistor on a circuit that was designed for this transistor? No, and it's absurd to think that you would, but you're going to get relatively the same performance within 10 to 15%, roughly. So therefore the box isn't garbage, because we don't want to go in at this, the time I'm making of this video, this part's now like $200. For this is roughly around 30 if you're buying them in lots of 1s and 2s. Okay, so we've achieved kind of a standard. This transistor will most of the way. Now in the boxes like iBuild or any of the other builders use, we've noticed that you have to modify the circuit just a little bit. You have to change 2 capacitors in the circuit to achieve absolute zenability, otherwise be able to get the most chooch for the chotch for dollars spent out of these transistors. It's not that far apart from this one though. It's a small amount. This other builder that's been having the pushback on that, he jumped onto this exact single piece of information and has been running with it like his penis is on fire. And the rest of us are sitting here laughing at him going, dude, chill out. It's the relative truth. These are the closest 2 components that we have in the market today that work relatively the same. My main concern and my motivation about the 2879C goes all the way back to several years ago. Several years ago, I got the test pieces from Brian Smith. I did my little load test to it, and then I said, okay, if you would like, I can send you back all the parts because I haven't done any destructive testing. Otherwise, you used them. What do you want me to do? He goes, well, can you build me a mono frequency amplifier and show me what its saturation points are? So I built this. There are no transformers. This is a transformerless amplifier. I learned how to make these from Shockwave out of Connecticut. Donald is his name. Very smart man. Nothing but respect. And I always give credit where I learned something from somebody. Smart man. He is the one that originally kicked me on to just doing pure inductor-driven mono frequency amplifier. And I thought to myself, well, instead of doing a broader band, and you guys get that, right? That the whole point behind using inductive coupling like this, or inductance coupling like this through a transformer, is to spread the response pattern of the circuit out so that we can utilize the transistor over a larger frequency range. Okay? There's a coil and a cap and a coil and a cap. Well, I've already done this test with the HG 1608 and about 12 other versions that preceded it, and the Toshiba, and I've got all that written down in a book. When I went and I did this transistor, it took wildly less inductor and a whole lot more capacitance for the part to be settled. The curve trace told me that. It's so radically different that I went to North and I said, North, I strongly suggest, and we have the emails to prove it, I strongly suggest that you use a different part number. And what my intention behind that was that I knew immediately that this was going to cause concern. Don't ask me why I saved this amplifier. I have no clue. It's sitting here for like 3.5, almost 4 years. I knew immediately that this situation would present itself, the problem that we're having today. And the whole point behind the Facebook videos was to try and help people understand what was taking place. And the reason I'm doing it here is for the exact same motivation. This transistor and this transistor are not interchangeable, not even remotely. The parts that you surround the transistors with look kind of the same, but there's more of them and the values are all different. Okay? Hence the reason this should have a different part number on it. I didn't care if you called them 2880s. The point is, whatever the part number was, I didn't want to have the 2879 component associated with it, this part, the original piece, because you have to set the circuit up so much differently. Me personally, and I'm not afraid to admit this, have yet to take an amplifier that was designed to run this part, or an amplifier that was designed to run this part, and try to convert it to run this component. I do know exactly what it would take to do it. I just haven't had any time to work on it. These two parts work roughly the same. That's what we call an interchangeable component. This part here does not. You have to load the circuit completely differently to make the circuit resonant to the part in the wafer design inside the transistor. So I'm doing this to help dispel the major issue that we're having. The whole point behind the last 3 videos, this one and the 2 on Facebook, is don't be deceived. Don't think that you can go and buy this transistor, put it in your amplifier that was built to run these parts, and think that you're going to get a performance increase. You are not. Once again, this part is not interchangeable with the circuitry that supports these 2 parts. You have to radically modify the circuitry that supports these components to make it work with this part. Now, this part standing on its own, dismissing these 2 from the conversation, is a great part. It's slightly more efficient. Well, what do I mean by efficiency? Well, when people go to talk about here, and I'm going to say it, Ohm's law, they always take the efficiency part of the equation and they drop it out their butt. They forget about it. Okay? So you have volts and amps equal watts, but the watts are divided by the efficiency of the component. Otherwise, how well this part is able to take electrons and convert it into working energy that you need over the heat loss value. The efficiency of the component is what everybody forgets. This is a little bit more efficient at that job than this part, and even this part. Is this part rugged enough to marry up with this part's output aspect ability, or otherwise to put up with high SWR? No, this is still superior, but only by a little bit. This part here is a pretty good part. It's on par with this one as far as reliability and toughness. This part here produces a little bit more power. This part here, in average mode, at 12.5 volts, at 12 volts worth of input saturation signal, or otherwise input signal, in a mono frequency amplifier will produce roughly 120 to 130 average power. The same with this, roughly. Plus or minus 10%. Plus or minus 10%, it says it right in the data sheet. This component, on the other hand, will do 130 through 140. So it's a little bit of an uptick. But now you take that same amount of uptick and spread it into something like a 24 or 48 pill amplifier. That translates into multiple big watts. It's a huge difference. So therefore, these 2 parts have to stand on their own, and this has to be its own designation. Okay, now that I've thoroughly explained that 4 different times, 3 different ways, there can't be any confusion. Are these 100% interchangeable? Yes and no. In certain styles of amplifiers, they sure are. In other style of amplifiers, they are not. They are not. Like when I have an amp come in here, I change 2 capacitors on each one of the sections to make it so that these parts work better at their optimum potential. Very clear about that. This transistor here, I know all the circuitry loading that goes with it. Heck, I'm the one that helped come up with part of the numbers. But see, North did this same process with a lot of different builders. I'm not a special little unicorn. Everybody got a chance at this. Everybody. What I've seen happen is people keep buying these parts and trying to drop them in their amplifier and thinking they're going to get better performance. You're not going to see that performance unless you modify the circuit around the transistor. So please, can we dispel with this rumor? I've seen it in tons and tons and tons of Facebook groups, the home of misinformation, I swear to God, and all over the internet, and everybody walking around with their chest puffed out like they're an expert. Oh yeah, no, you can drop them right. No, you can't. You cannot. And I'm going to show you what I mean. I have an example of this. from a third-party, non-biased builder. I got 4 test pieces. There's the 3 originals. Pay attention to the lot number down here at the bottom, by the way, you guys. 1710X8. Not built by me, but is here for repair. Let's look at the part number in the transistor. The original test pieces had a part number of 1710X8 on them. This is the current actual production run of the transistor. It is the 2879C 18D0 8 or 6, 8. Okay, let's step back just a little bit. My transformers are the same length as ICAs and X-forces. They are not the same length. That is another major difference, is that they require a different style of transformer, at least as far as size is concerned. If we notice, well, we have their 1000 puff cap, but then if we look right down here, let's go look at this one here. There's another capacitor below it. This capacitor is a completely different rating. Now I got to be careful what I choose to say here. I know all these numbers. I've had a lot of conversations with the guys that build these, and we've talked about a lot of different theoretical things. I know all the part values. I'm not going to come out here on Front Street and say I'm out for everybody to have something to say, or be like, oh man, why do we share? No, listen, I'm not going to be the one to let the cat out of the bag, but I'll tell you this capacitor, this capacitor, this capacitor, this capacitor, and this capacitor over here are all different. Also, your input tuning induction is way shorter, and also requires different capacitance. So therefore, even if I wanted to, I cannot snatch these 2879Cs out of here and put 1608s in here. I have to adjust this cap, this cap, this cap, this cap, and change this and that to make it work. I could adjust for this by changing this capacitance, adjust for the length of the transformer by changing that capacitor on top of the transformer. They're completely different. This is a perfect example. This is a production built, somebody else, not me, third party, like I said, built actual out the door amplifier. There are drastic physical differences if you know what you're looking for to make the parts work from A to B. So please, if we could dispense with the bull, it'll be awesome. 17C is a good part. I think that there's a lot of potential in it for the future. Honestly, it is what it is. They are not interchangeable. All right. Now, that all being said, opinions, they're like assholes. Everybody's got them. Let's not be assholes to each other. Gentlemen, my name is BBI. Appreciate you tuning in and check out what I have to talk about here today. Don't be deceived. Let's snub this little rumor in the butt. I honestly think that they should have had a different part number on them because they take such radically different circuitry, and it's not overwhelmingly radical, it's just slightly different. And I think I made my point. Got a question for me or something I can help you out with? Don't hesitate to call. Phone number's right here. Open Monday through Friday, 9 to 5. Come find me on Facebook. BBI Amps is the group. It's 3,000 something plus members, and we have a lot of fun in there. Take a minute, click subscribe. I'm always doing something like this. You guys have a good rest of your weekend, a good rest of your week coming up. I'll see ya. Bye-bye.